Are your food labels lying to you? Let's take a look at this nutrition facts information sheet that I got off of a loaf of bread that's in my house. Does anything look off about the calorie content? Notice that it tells you that a serving size is 2 slices. And it tells me that the calories in that serving is 150 calories per serving. It also tells me that there are 70 calories in 1 slice of bread. Now, maybe it's just me, but I would notice that, hey, there's 70 calories in 1 slice, and I instead eat 2 slices. That sure seems like it should be 140 calories. So the question is, are they lying? And if not, what assumptions are built into those numbers you might not be thinking about? That's what we're going to be looking at in this chapter. So consider this. What would you write down if you were in a lab, let's say one of your early labs in the semester, and you weighed out 2 objects, and they both weighed exactly 73 grams? But I told you you're going to round your answer to the nearest tens digit. Well, you would write down that the first piece of bread weighed 70, and the second piece of bread also weighed 70. I'm not going to win any awards for art, clearly. So we have 2 70-gram pieces of bread. But now, what if I weigh them both together and did the same thing? So if I take both my pieces of bread that are 73 grams, I'm going to get 146 grams on my scale. I'm then supposed to write down it rounded to the tens digit. Well, 6 is 5 or greater, so it's going to round up. So this is going to be 150 grams. So in this way, I could have had 2 objects that I wrote down as weighing 70 grams, but when I put them together, they weighed 146 grams, which gets recorded as 150. So in this way, no, that label isn't necessarily lying. There are just assumptions built in that you might not be thinking about with your measurement. So why do we need to understand measurement? Not just the assumptions I mentioned there, but in any number that you work with throughout this class or outside of the classroom space, there are going to be assumptions built into it, and we need to know what those are. So as a second example, if I told you that you could have 2 for $15, I think you would correctly ask 2 what? Numbers don't have meaning behind them until you attach a unit to them. So for example, if I was offering you 2 kilograms of gold for $15, that sounds great. You should also wonder where I got it and what the catch is. But if you could be given 2 kilograms of gold for $15, definitely take it up on that. On the other hand, if I had 2 milligrams of table salt and I was going to sell you that for $15, that's a pretty bad deal. Having said that, if you don't know a good feel for, okay, wait, you said a kilogram of gold, I'm not really sure what that is, or what's a milligram of salt, how much is that? We will also be working at throughout the semester as well. Because if those units of mass don't have a meaning to you, like if you can't think of what is about a milligram, then that sentence doesn't mean a whole lot. It's just, okay, 2 of something that I don't know much about. So one of our goals is to help you get a feel throughout the course for what do these different units look like. How much is a kilogram versus a gram versus a milligram? So we are going to look at, in this chapter, how we measure things, what assumptions are made in those measurements, and specifically, how do those assumptions get built into the numbers that we write down or read? So how do I do something in lab and then tell someone else how well I did it? Clearly, if I were making a pot of spaghetti and I put some salt in to the boiling water, I probably wouldn't be as accurate as if I was following a very careful recipe and I went, okay, this bread I'm going to bake, it tells me I have to be really exact. I'm going to put in 16.2 grams. Maybe you're not that careful, maybe you are. But there's a difference between if I was really careful and I tried to get it the closest 10th gram versus if I just kind of looked at a pot and dumped some in and went, it's good enough. And I, as a chemist, need to be able to tell other people how careful was I and how careful do I need to be. If nothing else, we worry about this question because being careful is harder. It takes up more time and it costs money. So we want to be able to say, if I took the time to measure something really carefully, I want you to know that. And in my directions, if I don't want you to waste a bunch of time in lab, I'm like, look, in lab, yes, the directions say 100 milliliters, but it's okay if it's 110 or if it's 90. You just have to be close. I need a way to tell you that information so that you don't spend a lot of time trying to get to 100.0 milliliters using a little dropper where you spend 5 minutes to try to measure something or maybe a minute, and I meant for you to take about 10 to 15 seconds, just put under a faucet and get some water. So to do this, we need something we call a unit of measurement. So what is a unit of measurement? Units are going to be words or symbols written after numbers to give context to what they are measuring. So for an example that you are probably pretty familiar with, if you had 200 cents, that's very different than if you had $200. So the cents or dollars describes that number so that 200 has more of a meaning. Similarly, if I had $200,000, that would be more than $200. Be a different number as well, but we worry about what are the other descriptors that we have. How do those help us know what it is we have? So there are two most common systems of measurement, at least from the context of our class and learning about chemistry in America. One is the English system. That's the one the United States uses. This includes things like feet and pounds. The second is the metric system. This is the one used by most of the world, and scientists use it almost exclusively, and it includes units like meters and grams. Scientists are specifically going to call their system of measurement the International System of Units, or SI. Sometimes you might hear professors in a class or other scientists talk about SI units. Those are going to be the ones we're going to talk through in this class. So that's what we're going to be going on from here, is what are the units that scientists use to make measurements and to help you get more familiar with those if you haven't heard of some of them before.